Welcome back to the Canadian Masonry Podcast. Today we're digging deep, literally into the red clay that builds our cities.
That's the plan. We're really gearing this deep dive for, the first and second year apprentices out there.
Yeah, the real coffee break wisdom.
Exactly. We're going to trace the brick's whole journey from the ground up, and we'll get into the critical CSA A82 standards here in Canada, because that's something you just have to know.
Okay, let's unpack this then. We're talking production, the science of the kiln, the Canadian grade and type system, and why every single millimeter matters when you're dealing with modular sizing.
Let's do it.
So let's start at the very beginning. The raw material.
Yeah.
It all kicks off with processed clay and shale, right?
Right, and for anyone wondering, shale is really it's clay that's been under immense geological pressure for millions of years.
So it's super compressed clay.
That's it. But what really matters is the chemistry. Clay is mainly silica and alumina. The color, though, that comes from metallic oxides in the deposit.
So that classic brick red.
Mm-hmm.
That's iron oxide.
You got it. And if you're laying browns or grays, even blacks, that's usually from manganese oxides. The whole process starts with mining it, or what the industry calls winning the clay.
Winning the clay. I like that. So once it's won, you've got to mold it. And the big difference between the methods is just water content.
Pretty much. It all comes down to water. The oldest method is soft mud.
Okay.
And it is exactly what it sounds like. Very wet. We're talking 20, maybe 30% water. That mix gets pressed into molds.
And they have to coat the mold so it doesn't stick, I'm guessing.
Exactly. You either use sand, which gives you a sand mold texture, or you use water. That creates what's called a water-struck finish.
Right, I've seen that.
Yeah.
It has that sort of historic handmade look to it.
It does. It's an aesthetic choice, really. Not as common, but you see it on certain jobs.
So what's on the complete other end of the spectrum?
That would be the dry press method. Very, very little water, 10% or even less.
Just barely damp.
Right. It's almost like dust. And it gets compacted into a mold by a plunger with thousands of pounds of pressure.
And why would you use that method?
Precision. You do that when you need absolutely perfect dimensions and, most importantly, super sharp arises.
The corners and edges.
The corners and edges, got to have them crisp for certain designs. But, for the vast majority of bricks you'll see on a Canadian site, that's going to be the stiff mud process, extrusion.
The workhorse.
The modern workhorse, yeah. It uses about 12 to 14% water. The clay is forced through a steel opening, like a long, continuous column.
Like a giant sausage of clay.
Perfect analogy. And then automated wire cutting machines just slice it up into individual bricks.
And that process is what gives it the highest compressive strength.
It is, because forcing it through that die under pressure gets rid of air voids and makes it incredibly dense and uniform. That consistency is everything for our climate.
Okay, so once the machine cuts that column, we've got what's called a green brick. It looks like a brick, but you can't just throw wet clay into a wall.
No, you definitely can't. That moisture would just cause it to crack and spall later on. So first, they're stacked on a kiln car and they go into a dryer.
To get that moisture out.
All the way down to about 0.5%.
And then it's time for the heat. We're talking serious temperatures. Right?
Oh, yeah. For face units, you're looking at 1,000 to 1,400 degrees Celsius. Fire brick for chimneys and stuff goes even higher, up to 1,550.
And the whole firing process can take, what, a few days?
Up to 3 days, yeah.
Yeah.
This is where you create that permanent ceramic bond. It's what turns clay into, artificial stone.
Speaking of cooking, I told my buddy I was going to work at a brick plant, and he asked if I needed to know how to bake.
Uh-oh.
I told him, well, we do fire them at 1,000 degrees, but if you try to eat one, you're going to need a very expensive dentist.
Yeah, no question. A very expensive dentist. But that intense heat creates a process called vitrification.
Vitrification. Okay, break that down for us.
It's when the heat fuses the silica grains together and starts to close the material's pores. It makes the brick partially glassy, which is key for durability.
So it's all about controlling how porous the brick is. What happens if it's, say, undercooked?
Well, high porosity means high absorption. That brick will suck water out of everything, out of the air, and more importantly, out of your mortar.
Which kills your bond strength.
Kills it. We measure that with the initial rate of absorption, or IRA. A high IRA means a weak bond and disaster in a freeze-thaw cycle.
And what's the other extreme? Overcooked?
That gives you clinker bricks. They're overburnt, often misshapen and almost totally non-absorbent. They're basically glazed solid.
I've heard of those.
Yeah, historically, masons would use them at the base of a wall specifically because they wouldn't wick moisture up from the ground. It was kind of happy accident.
Let's talk about the holes in the brick, the cores. They're made by rods in the extrusion die. Right. It seems weird to poke holes in something you want to be strong.
It does seem counterintuitive, but there are some really practical reasons. One, it's less material, so it's lighter and cheaper. Two, the holes help the heat distribute evenly during firing.
Okay, that makes sense.
But the big one, the crucial reason for you on the wall, is the mortar bond.
How does that work?
When you lay the brick, the mortar squishes partway into those cores. It creates a mechanical lock, a shear key.
Ah, so it's not just sticking to the surface, it's physically locked in.
Exactly. It massively improves the wall's resistance to, lateral forces like wind. The cores actually make the whole wall system stronger.
That structural integrity has to be standardized, which brings us to the mandatory stuff.
Yeah.
For any apprentice in Canada, you have to know CSA A82-14.
You absolutely have to. That's the standard for fired masonry brick made from clay or shale. It defines two things you'll see on every spec sheet: grade and type.
Grade is about weather resistance, and type is about size tolerance.
That's the breakdown. And in Canada, grade is everything. You'll see grade IG, which is interior grade, but you almost never use it on an exterior wall up here.
It's just not tough enough for our weather.
Not even close. What you need, and what's the default legal requirement if nothing is specified, is grade EG, exterior grade.
The workhorse.
The only horse in the race, really. It has to pass these brutal tests for low water absorption and high strength to survive our freeze-thaw cycles without falling apart.
Why do Canadian bricks have such a high GPA?
I don't know. Why?
Because they have to pass grade EG just to survive a Tuesday in Winnipeg.
That is painfully true. Yeah, it's serious stuff. If you see a pallet on site for an exterior wall, find that grade EG stamp. In Canada, if it ain't EG, it's basically a paperweight.
Okay, so that's durability. Now let's talk precision. That's the type classification.
Right. There are three. Type S is your standard general use brick. It allows for small variations in size that, the mortar joint just eats up. You'll never notice.
Then you got Type X.
Yeah, Type X is for high precision work. The tolerances for size variation are much, much smaller, and they're way stricter about chips and cracks, especially on the arises.
So if an architect wants a perfect stack bond, where every joint lines up,
you need Type X. If you try that with a Type S brick, your lines will wander all over the place. It'll look terrible.
And the last one is Type A.
Type A is architectural. That's where the rules get thrown out a bit. They're made to vary in size or color or texture on purpose to get a specific look. The designer and the plant just agree on an acceptable sample range.
Got it. Now let's talk about the math on the wall, the size. You need to be clear on actual versus nominal size.
This is fundamental. Actual size is just that. You take a tape measure to the brick width, height, length. That's the actual size.
And nominal size.
Nominal size is the actual size plus one mortar joint. And here in Canada, with the metric system, that joint is pretty much always 10 millimeters.
So a 57 millimeter high brick has a nominal height of 67 millimeters.
Exactly. And that's why the modular standard is so dominant. It's all designed to work with that system.
An apprentice asked me why we use modular bricks. I told him it's because standard bricks were feeling a bit small for the job. But modular bricks really know how to scale a project.
They do know how to scale. The whole point of modular is how it lines up with other building materials, especially the standard 200 millimeter concrete block.
The 3-to-1 ratio.
That's the magic number. Your standard metric modular brick has an actual height of 57 millimeters. So you stack three of them. 57 plus 57 plus 57.
That's 171.
Right. Now add three 10 millimeter mortar joints. That's another 30 millimeters.
For a total of 201, wait, 200?
It's 200 millimeters, exactly.
Yeah.
And what's the nominal height of a standard concrete block?
200 millimeters.
See? 3 courses of brick perfectly match 1 course of block. It saves a massive amount of cutting and headaches on site.
So what are the common actual sizes we need to have memorized?
Okay, the big 3 you'll see are metric modular, which is 90 wide by 57 high by 190 long.
Got it.
Then there's CSR, or Canadian Standard Residential. That's 90 wide, 70 high, and 230 long.
And king size?
King is a little different. It's usually 80 wide, 70 high, and 240 long. The CSR and King are taller, so you lay fewer courses, but you lose that perfect 3-to-1 alignment with block.
Good to know. You have to know what's on the pallet before you even start.
You have to.
All right, let's wrap this up with the key takeaways.
Okay, for the apprentice on site. Number 1, Always check for that grade EG certification. It is the minimum for our climate. 2, if the job is high precision, like a stack bond, you need type X. And 3, remember, those cores are your friends. They give you a much better mechanical bond with the mortar.
And we kept coming back to water absorption. The IOA, that's especially important if you ever have to work with reclaimed brick.
Oh, absolutely. Reclaimed brick can be all over the map with its absorption rate. The rule of thumb is if a unit soaks up more than 30 grams of water in a 1-minute dip test, you have to wet it before you lay it.
And that's not just a quick spray with the hose, is it?
No. That means soaking it the day before. You want the inside of the brick to be saturated so it won't steal water from your mortar, but the surface needs to be dry when you actually lay it. That moisture control is just as important as keeping your wall plumb.
Great advice. Keep your courses straight and your mud consistent. Next time, we're talking mortar mixes, what goes into that perfect blend and the different types of cement you'll be working with. See you on the scaffold.